This session going to be discuss the about a virtual memory concept. It is a part of the memory system model 3 of computer organization course. So the presentation flow as follows. At the beginning, we'll go to discuss the very fundamental concept of virtual memory. Continuation of this, the organization of the virtual memory, and further there is a after organizing there is a CPU releases some address, so that address will be translated into physical address. So virtual address released by the processor, so that going to be convert into, so that is a address translation mechanism going to be discussed. So when going to be translate this address, so there is a phase fault will be occur, or page contention will be occur, conflicts will be occur. So all those information going to be maintained in the logbook like translation look side buffer called TLB and page table, right? So these two data structure going to be help us to accommodate or place these pages systematically into the memory. So for that, transaction records will going to be record in these two data structures. And after that, so there is a associative map TLB organization will going to be look after to manage this page faults, so on, that is. So and also that is a translation looks side buffer coherence we need to be maintain that consistent record that reveal the latest updated information about the various pages, the movements, whether that page is old, whether the page is updated. So all those kind of information that consistency will going to be observed, that is. Finally, that how to handle this phase fault technique going to also discuss. So these are the some milestones in this discussion. So having following this concepts, so let we call that is a virtual memories. Virtual memories, here we can discuss that is the design of system, and we can have we can have that memory system and at a affordable cost. So we can have that is about the what we can say architecture solution regarding that the increase in effective speed and size, right? Speed and size go on, that is going to be discussed, that is. So let we see that size and memory storage. Cache memory were developed to increase the effective speed of the memory storage, that is a memory system. Virtual memory is an architecture solution to increase the effective size of the memory storage. So recall that addressable memory space depends on the number of address bits in a computer. So the number of address bits have generated by the computer, so that is going to be handled by memory management unit. So that memory management unit will welcome the address which is sent by the CPU or computer. So that is going to be explore and analyze. After analyzing, it will able to understand the where that kind of locations are exist in the memory layout. So that is a example. If computer issues 32-bit address, the addressable memory space is 4G bytes, right? 4G byte, that is computable. It refers to the 4G byte, that is. So here physical main memory in a computer is generally not as large as the entire possible addressable space. We will see that the physical memory may not large as addressable space. So for which the physical memory is typical range from hundreds MBs to 1 GB bytes. 1 GB bytes. So I hope the main memory of the most of the computers. So virtual memory, the large program that cannot fit completely into main memory. When during execution program, user submit the huge program contains the several lakhs of lines. So that to be huge memory is required. So having understood or having known the size of the program which is submitted by the user, so that is not possible to keep that entire program in a main memory. So their parts are stored in a secondary storage devices such that magnetic disk. So the entire program asks them to sit in a magnetic disk, that is a secondary storage. After placing there, we can bring that program part by part. So partition the program or segment the program. You call segment by segment in a sequence. In other words, all segments or all partition of the programs is not required in a single stretch at a given amount of time. So we can call in a sequence partition by partition or segment by segment or piece of that programs. Pieces of program must be transferred to main memory from secondary storage before they can be executed, right? So I hope it is clear. Users submit the program which is a need a huge space, so that all entire body of the program not necessary to call. So the better ask them to stay at the secondary storage. So when execution commence, so we can call piece by piece of that program, right? So like that user think that the entire program going to the main memory to execute, right? So that is happen. So but virtual memory, it creates the illusion towards the user. So I have submitted the big program, but main memory is very less, though I got a executed results. But inside that virtual memory, that is a software approach, help us to split this program and execute in a piecewise manner. When a new piece of program used to be transferred to main memory and the main memory is full, then some of the piece in the main memory must be replaced. So having understood, so entire program will be split into segment or partition. So after splitting and putting that partition, so what will happen, that is the program will call one by one and ask them to stay at a main memory. By doing so, at a given instant of time, main memory become full. If so, some of the main memory blocks we should replace or remove from that and make the space for the new partition of the program or new piece of the program. So what will happen, that is only the piece of program or partition of the program which have currently work at the CPU, only those can stay in the main memory, because the main memory is very small. We cannot place entire program or maximum portion of the program. So only the program piece or which is going to be anvil of the CPU going to be executed. So only such portions we can keep in the main memory. Some other piece in the main memory must be replaced. So recall this very similar to what we studied case of the cache memory, right? So cache memory also so maintain the the what is a speed gap between the processor and main memory. So now there is a size gap between the main memory and secondary storage. So in order to do so, the virtual memory concept help us. So having understood these concepts, so let we proceed further. Operating system, that is OS, automatically transfer the data between main memory and secondary storage. The responsibility of operating system. So as a governor, it is a governing management, the governing organization of this entire computer system by the operating system. So that is the parallelly transfer the data between this main memory and secondary storage. Application programmer need not concern with this transfer. So application program may be C or maybe Java or maybe any programming application programmer need not to be concerned worry about this. So this will be performed by the operating system on behalf of user. Also, application program does not need aware of this limitation imposed by the available physical memory, and also that is a they're not necessary to worry, not necessary to think about the though have small amount of memory. I am going to submit a bigger program, how it will be executed. So that is not concerned to the programmer, it is left to the system, computer system, under the guidance of the operating system, that will be performed. So techniques that automatically move program and data between the main memory and secondary storage, that is disk, when they are needed for execution, are called a virtual memory technique. Right? What is a virtual memory technique? So whenever the request come from that what is called processor, so that data will be transfer, program and data will transfer between the main memory and secondary storage. So when it is the need, that is a guidance of this processor and also operating system, so that will be supplied, right? So that is called a virtual memory. And also the adjust the size gap between these two, main memory and secondary memory. So program and processor reference and instructions or data independent of the size of the main memory. So that reference and instruction or data are independent of the size of the main memory. Processor issue binary address for instruction and data. So processor send. So when executing the program, so after executing or starting of the execution, so the instructions address is essential. So that address, in order to bring those instructions, it may be available in the cache memory or main memory or secondary memory. So this path will be followed. Is issue an instruction, please bring this instruction wherever it is available. Possibilities are cache memory, main memory, secondary memory. So these three devices are, as you observed, hierarchy of the memory. So in that line they were there in the path. So with help of this address, the memory controller and other person who assisting to the processor to perform the execution of the program, so they will take a responsibility to bring that instruction or data. Right? So these binary address are called logical or virtual address. Right? So this logical or virtual address will be released by the processor. So virtual addresses are translated into physical address by combination of the hardware and software subsystem. Right? So hardware also help us, software also involved to convert this given virtual address or the what we call logical address into physical address. So that will be involved. If virtual addresses refer to part of the program that is presently in the main memory, so with respect to the main memory, that will be talk, that processor will talk. So this is currently available at main memory, so it is accessed immediately. So by sending some address, it will demand. If the address refer to the part of the program that is currently in the main memory, so it is first transferred to main memory before it can be used. So it can transport to the memory before it can be used. So the virtual memory organization, we can observe here, see that the memory management unit. So what is a memory management unit? So certain responsibility taken by the unit called memory management unit. So the job of the memory management unit, the processor will send some address, so that is a virtual or logical address. So this address will arrive to the memory management unit. So that will be in the premise of the CPU, but not as a part of the processor. It is just outside the processor. So the address released by that processor, it will report to the or reach to the memory management unit. So the memory management unit, it will analyze that virtual address and try to translate into physical address. The physical address is help us to bring the data or instruction which is available at the main memory. So that is a significance of the or the major responsibility of the memory management unit. So what is this actually? It is just like a the data structure. It is just like a on the logbook. It manage the show here. So conversion. So what is a conversion? Logical or virtual address translate into physical address. So if the desired data instructions are in the main memory, they are fetched described previously. So that data which is requested by the processor, it is in the main memory, they fetched as a described previously. So how we can know that whether it is available or not? So it will go to the main memory and that address will be searched there. So that corresponding address holding the instructions or data, then we can say main memory hit occur. Otherwise it is a false occur. Otherwise it is a miss occur, right? Hit and miss. That is a hit rate is going to be higher if the performance is better. So if the desired data or instruction are not in the main memory, they must transfer from secondary storage to main memory. So currently we understood if it is not available in the main memory, then what is the next hierarchy of the memory? Others, that is secondary memory. That is a secondary storage. So secondary storage is a magnetic disk. So there that instructions are data which is requested by the CPU right now, which definitely available at the secondary storage. It is definitely available at the magnetic disk. Then that instruction we have to bring and supply to the processor. And also before supplying to the processor, the copy of has to be submitted to the main memory. So in future the same instruction or data might be requested by the request from the processor. So having known this, in future it may request arrives, it may request occurs. So in that sense, that is a future plan. So you can keep that instruction here and also give it to processor, right? So the memory management unit causes the OS, that is operating system, to bring the data from secondary storage into the main memory, right? So operating system will assist in that sense to give a copy to the main memory even if that copy is not available at the main memory, right? So from this we can see that the processor is a data coming from that main memory. So in order to bring that data or instruction from the main memory, processor need to send address where that data or instruction reside at the main memory. So that address processor has to give. So processor is not sending physical address, it's sending logical address, right? That is a virtual address. So that virtual address will reach to the memory management unit. So memory management unit is a ambassador or is sat between the processor and main memory and synchronize or act as a the assistance to assist to the processor the data which is required by the processor. So that data has to be supplied to processor. So the memory management unit will take that responsibility. So also in order to serve that the request of the processor or demand of the processor, the virtual address will be or logical address will be convert into physical address. So physical address which help us to identify the location at the main memory, right? So that is a cache memory. So before going to the cache memory, they're very close to the processor is a cache memory. So that cache memory is try to adjust the speed gap between the processor and main memory we have discussed in the previous session. So that is a speed matcher between this processor and main memory. So there is also chances that requested byte or word which may be available at the cache. If it is available the cache, that is a cache hit occur. If not, cache miss occur. If cache miss occur, it is a burden to the entire system. So we need to be spend more memory cycle. In other words, we have to go to the next hierarchy of memory called main memory, right? So the main memory is able to find out with help of the physical address. So the main memory, again it will go to the if it is a main memory miss occur, then it go to the disk, right? That is a hard disk. So that is a secondary storage. So in order to bring the data from a secondary storage, we have the mechanism called direct memory transfer. That is a direct memory transfer which help us to transfer in a bulk or burst mode. We have discussed in length in the previous video lecture. So that is a disk storage which help us to bring that data. So having understood this concept, so the address translation mechanism going to be discussed in the subsequent slides. That address translation, we have seen that the processor will provide logical address or virtual address. So this address need to be converted into physical address. Assume that program and data are composed of fixed length unit called pages, right? So program is a notebook, right? So notebook contains the several pages. Similarly, program and data are composed of fixed length unit called pages, right? If you call a program as an entire notebook and notebook contains the pages, similarly the program as a notebook which contains the pages which are informations are data and instructions, right? So that have a the fixed length units, right? So page consists of block of words that occupy contiguous locations in the main memory, right? So that page consists of block of words. Program is a set of pages. So page consists of set of blocks, right? So block of words, so that occupy the contiguous location in the main memory. Page is a basic unit of the information that is transferred between secondary storage and main memory, right? So what is a page? Page is a basic unit of information. It is a block of words, that is a block of instructions or data. So that is the smallest unit of the program. So that is can be transferred or the exchange between the secondary storage and main memory. Size of the page commonly ranges from 2 kilobytes to 16 kilobytes. So 2 kilo to 16 kilobytes of the size of the each page. So pages should not be too small. Page may not be too small or may not be bigger. So because the access time of secondary storage device is much larger than the main memory. So you know that main memory is a electromechanical device. Secondary storage is a further electromechanical device, in the sense it is a inherent property. It may basically slow, right? So that's why the page should be a moderate size. The pages should not be large, else large portion of the page may not be employed and it will be occupy valuable space in the main memory, right? So main memory space is vital, it is most important. So we have to provide that space for only very important blocks of the pages, right? So you can, if you bring a huge amount of blocks or size, then it will be occupy main memory. So in that only certain instructions are needed for the processor. Instead of supplying only certain instruction, keeping all entire block of that program, it is not an essential. It is not a needed there. Only the instructions or data requested by the processor, which is available in the any page of the this virtual memory, only those blocks we need to be supplied. So that is the intention behind that, or in other words, effective usage of the main memory is a most important factor. So further, concept of virtual memory are similar to the cache memory. So we have said or we have discussed enough about that. So concept is same. Cache memory adjusts the speed gap between the main memory and processor. Virtual memory adjusts the size gap between the main memory and secondary storage. So cache memory so introduce the bridge the speed gap between the processor and the main memory, implement with help of the hardware. So that we have discussed, that is a memory mapping techniques. What are those? The direct mapping policy, the associative mapping policy, set associative mapping policy. So those mapping policies try to replace or place the block in a cache memory with various algorithm. We will discuss that is. So that is implemented with help of the hardware. The virtual memory introduced to the bridge the speed gap between the main memory and secondary storage, also size gap, implement in the part by the software. So having understood these concepts, each virtual or logic address created by the processor is understand as a virtual page number, right? So address generated from the processor and it reached to the memory management unit, right? To before going to the actual location of the either cache or main memory, it report to the or it reached to the memory management unit. So that memory management unit is a split or understand the entire logical or virtual address split into virtual page numbers. Higher order bits of that address from the processor will be considered as a virtual page number plus an offset, that is a lower order bits. So that is specify the location of the particular byte within the page, right? So program will be split into pages. So pages will consist of set of blocks, words, right? Blocks of words. So that blocks words we can identify by this logical address. So that virtual logical address will have two component. The higher bits will be virtual page number, lower bits of that logical address will be offset. So which help us to identify the byte within the page. So information about main memory location, each page is kept in the page table. So main memory location logbook. So which are the pages are coming, which are the pages are went, which are a page, age of the page, right? So how old that page, if the very old was page, then that contains the old data, so update it. All those kind of the logbook information, it is available in the page table, right? So page table is again data structure which contains the up-to-date information of all the pages which are available right now in the main memory. Main memory address where the page is stored, so current status of the page. So area of main memory that can hold a page is called a page frame. The area, certain area of the main memory that can be hold pages is called a page frames, right? So starting address of the page table is kept in the page table base register. So the page table have the additional component to help to identify the pages for which we needed the starting address by the page table base register. So base register will tell the starting address of the page table, right? So that is a base register is a one more component. So that is a virtual page number address translation. So virtual page number created by the processor is added to the contents of the page table base register. right? So as we see, processor send logical or virtual address which contains 16-bit, 32-bit or depends upon the architecture. So that entire logical address or physical address split into two components. One component, that the higher bits represents virtual page number, and the other component, lower bits, will be offset. The virtual page number tells about the starting address of the page table. So that starting address of the page table. So that is a base register. And offset is a length of that, how far from the starting address, how far from the first space of the data. In a page table, there is a first location, and from that there is a distance will be there. So that is called offset, which is mentioned from the virtual address or logical address, which is generated from the processor, that is a lower bits of the logical address. So this provides the address of the corresponding entry in the page table. Provide the address table in the corresponding entry in the page table. So contents of this location in the page table give the starting address of the page table if the page is right now in the main memory. So sometimes page may not available, page is went, page is removed due to the dirty, due to the age, so due to the old data. So all this, the status of that particular page will be there. Due to all those pages are may be removed or may be available. So that kind of complete information of that particular page will be is there. So continuation of this. So let we see diagrammically how this will be happening. So virtual address from the processor. So as we said, it is a bundle of bits will be there. So again depends upon the architecture. It may be 16-bit. It, for example, 8086 is a 16-bit. Maybe higher, maybe 80, maybe 286, 386, maybe 32-bit. So that address, virtual address, will be coming from the processor. That will be split into two components. One is called, the higher bits will be virtual page number and lower bits will be offset. What is a virtual page number? It is a starting address of the page table. So which is going to be there in the base register, page table base register, and offset the distance from the starting to where it is located. That is a distance, that is offset. So this we are going to be understand. There is a page table base register, right? So page table base register contains this virtual page number. So the page table base register holds the address of the page table. So base register holds the address of the page table in the memory, right? In a memory, so there are several tables are there. One such table called page table. Page table, for that table there is a starting address called base register. So that base register holds the address of the page table. So the page table base register plus virtual page number provides the entire entry of the page table. This virtual page number from processor, so and the base table base register. So these two component will be added. What is the base table address? The starting address of the page table, right? So the table, the page table about the information of the pages which are currently at the main memory. So those page table address where that page table available in the main memory. So that address is available in the base register. So that is called page table base register. So page table base register have address. So this virtual page table page number and this base table together will form an address, right? So this this plus this will generate the address of the page table, right? We have page table. So this is a starting address. Page table base register is a starting address of the page table. After adding this virtual page number, we will get an what is called the correct location in the page table. I hope you following. That is the correct location of the page table. This is essential for us because so this is page table is there. So this starting address is there in the page table address, and processor sends some page number. So that will be get added, and you will get a what is called the exact location of that instructions or data requested by the processor. So the first part of this page table is a control bits. So maybe a dirty bit, or maybe status bit, or maybe validity of bit. So all those. So this is a page frame in a memory. The particular instance of that particular page, certain portion will related to blocks of the word of that page. So that is a page frame in a memory. So this is a page frame. For example, so this we have identified, and this is a entire this is a page frame, right? So page frame. So page table holds the information about each page. It holds the this includes the starting address of the page table in the main memory. So virtual address is interpreted as a page page number and offset. So it is arrived, that is we have received from the processor. So this entry has the starting location of the page. So here, so after adding virtual page number and base table address, we will get a location. From that we can drive out information page frame. So this page frame will be drive out. So this page frame will be bring out, and so the location called page frame. Directly offset will be there, which is sent by the processor. So these two component, one component from the offset, that is from the processor, the other component which is after doing some calculation we got information from the page table, that is a page frame. So this together will form a physical address. This will be help us to obtain the physical address. From this physical address, so we can go to the page table entry or cache memory or main memory. Page table entry for the that is a page also included some control bits. So control bits which are seen in the previous diagram, so which is describe the status of the page, which is right now in the main memory, which show that page is actually loaded into main memory. So one bit indicates validity of the page, that is currently located into main memory, allows the operating system to invalidate the page without actual removing it. So OS invalidate the page without disturbing that page into main memory. So just update the status bit. From that status bit, so we can easily identify that that is a invalidate or old page, so that no more consideration will be there. So that place will be think always vacant. In other words, we can place new pages whenever arrive in the next sequence. One more bit indicates the page has been modified during the residency in the main memory. So if pages updated, so that information is also there. This bit determines whether the page should be written back to disk when it is removed from the main memory. So in order to give it back to disk, it is noted there, page should be sent back to disk when it is removed from the main memory. So having understood, similar to the dirty or modified bit in the case of the cache memory, we have seen that. So that is also translation look side buffer. So translation look side buffer, the all other control bits of other type restriction that may be imposed other than this the status bit. Program may only have read permission for a page, but not write or modify permissions. So in that case, the small cache called translation look side buffer. So this is also called as a cache, which is a small buffer kind of, that is, which is called as a translation look side buffer TLB, is included in the memory management unit. So that memory management unit very close to the processor, right? So TLB holds the page table entries. What is a page table? Page table is a matrix or data structure which act as a logbook. What are the pages currently available in the main memory? So that their status, their age and all those kind of information available at the page table for the most recently accessed pages. Cache memory holds most recently accessed blocks from the main memory. Similarly, so translation looks side buffer which has help us to this what is called virtual memory, whereas cache memory which help us to that is a memory mapping technique. So operation of the translation look side buffer and page table in the main memory is similar to the operation to cache memory and main memory. See, the page table entry for the page includes address of the page from where the page resides in the main memory and some control bits. So page table entry the further explicitly contains the page resides in the main memory and other control bits. In addition, with the help of the TLB must hold the what is VPN for each page, virtual page number for each page. So that also contains. So continuation of this. So where should page table be located? Page table. Recall that page table is used by memory management unit, which is very close to processor for every read and write access to the memory. So that is the information there, right? So ideal location for the page table is within the main memory unit. Memory management unit. So memory management unit provide a small space for page table. So every job have a page table. So page table is quite large. Sometimes memory management is implemented as a part of the processor chip. So some of the part can also it give the custody to processor chip. Impossible to include a complete page table on the chip or in the processor. Processor premises you have very less space, that is a very less number of registers are there, small amount of buffer would be there, so there it is quite impossible to keep them. So memory management unit will look after the status or look after the entire information about the page table kept in the main memory. So the copy of small portion of the page table can be accommodated within the main memory unit. So portion consists of page table entry that correspond to the most recently accessed pages. So in this direction there is a associative mapped translation look side buffer. That translation look side buffer made processor select the virtual page. So the virtual address from the processor, as we seen in the previous discussion, when you observe the organization of the virtual memory, so these bits are compared with the virtual page number in the translation look side buffer. So TLB it is a some information about the page table. So that page table contains the page information which is available in the main memory. That abstract version of that all the pages information is a TLB. So that TLB will be there at memory management unit. Then the virtual page number will be sent by the processor. So virtual page layout of the virtual page number is there, and it contains the control bits, and it contains the page frame in a memory. So this is a complete translation look side buffer. So we can differentiate from the previous concept what we discussed, that is called page table, right? Page table layout and virtual memory organization. Now we are discussing the TLB. TLB is what? TLB is a abstract version of the information about page table, right? So the page table entire information may be more, that we cannot hold or keep entire. So instead of remembering all those, so the abstract little brief information about a page table will be TLB, right? So TLB is there. So this TLB contains these three components. So we have If there is a match, a hit occurs and parallel address of the page frame is read. The simultaneous address of the page frame is read, that is. So page frame address will be read. So we have the virtual page number and so all this virtual page number information will be coming here and compared with the virtual page number here and virtual page number in the TLB. So this virtual page number coming from the processor, the virtual page number already available in the TLB. So this both are equal, then we can say hit. In other words, so those page which is right now it is available in the main memory. So that is a indication shown by this hit results. If there is a match, a hit occurs, parallel address of the space famous is read. So if it is match occur, then there is a several page numbers are there. So among this, any one may be match, then it indicates which is available in the main memory. So if there is a no match, then that is a miss, means it is not available in the main memory. So occurs, then the page table within the main memory must be consulted, right? So that is a miss occur. So if no match between this virtual page number sent by the processor and the page number available in the TLB, if no matching, then the miss occur. It, in other words, it is not available in the main memory. So set associative mapping TLB are found in commercial processor, right? So this we can, if it is a match occur, then page frame will be bring out and added with the offset, then altogether will form a physical address in the main memory, right? So if not, then it will go to secondary storage. There that byte maybe is available, and from there we have to bring it, right? So the coherence of or consistency of this TLB translation looks at buffer. So how to keep the entries of the TLB coherence with the contents of the page table in the main memory? I hope it is clear. Coherence means it is a consistency. So consistency means what are the pages information available at the page table, and that abstract version is available at TLB. That should be latest, that would be updated, that would be have latest modified the results or modified pages. So that information should be original, that information should not contain the duplicates. So that is the coherence. So coherence information should be available at TLB. Operating system may change the contents of the page table in the main memory. That is also, there is also possibility, right? So simultaneously it must also invalidate the corresponding entries in the TLB. If it changes the information at the page table, and the respective information will be modified in the TLB also. So control bits is provided in the TLB to invalidate an entry. So control bits are there. What are the changes happen? If an entry is invalidate, then the TLB gets the information for the entry from the page table. So that could be get updated from the page table. Follows that same process that would be follow if the entry is not found in the TLB, if in miss occur case. So same process will repeat in the case of miss occur. So also phase fault. Page fault, what happens if the program generates then access to pages that is not in the main memory? So that is a phase fault. Particular page requested by the processor, but that page is not available right now in the main memory. So that is a phase fault occur. Phase fault means, so that is the penalty is there. Penalty will be occur here. Penalty means the associated system may not able to supply the instructions or data which is requested by the processor immediately, because which is not available right now at the main memory. So we have to spend more clock cycle to bring that data where it is available. Of course it may be available in the secondary storage, that is a hard disk. So it has to spend more time to bring that. So that's why that is a penalty. That's why system hurdles will be created here, right? So disturbance delay will be established here. In this case, page fault is said to be occur. Whole page must be brought into the main memory from the disk before execution commences. So upon detecting the page fault by memory management, the following actions are taken. Memory management asks the OS to intervene by the raising an exception. So memory management will, when it will be, take the help of the OS. So OS is a supreme, right? So it will be running the entire show of the system. So it will take the help of the OS, ask them to introduce some interruption or exception, raising an exception. So processing of an active task which disturb the page fault is interrupted, right? So currently the page is not available, so with that which creates the disturbance here. So that will be active task here. Control is transferred to the OS. Memory management will hand out the entire controlling mechanism to the OS. So person OS, please get involved here. You are being a supreme to this system. So the certain page not available. Now page fault occur. So you have to use the highest priority and bring that page where it is available. So of course it is available secondary storage. So OS copies that requested page from the secondary storage to main memory. Once the page is copied, control is returned to the return to what is task, what is that is task which was interrupted. So page fault servicing of page fault, that is PF, requires transferring the requested page from secondary storage to main memory. This transfer may incur long delay, right? So this is secondary storage is a basically mechanical oriented electromechanical device. Is have inherence, it have natural property or being small. It may perform in terms of milliseconds or sometimes nanoseconds or sometimes seconds also, whereas processor goes in nanoseconds and picoseconds. So this transfer for the processor, it going to be very costlier. So while the pages is being transferred to the OS may suspend the execution of the task that is caused by the page fault. So begin execution of another task whose pages are in the main memory. So enable the efficient use of the processor. So we can make use the efficient use of the processor. How to ensure that interrupted task can be continue correctly when it resume the execution. So when arrives at page fault, the page that which creates the fault, after that it has to resume the remaining execution. So there are two possibilities. What are those? Execution of the interrupted task must be continued from the point where it was stopped, right? So when the page fault occur, due to that suspended the remaining execution of the program, right? So now that page has came back, then once it came back and continue the execution of the continuation of the execution will commence from the where it was interrupted. The instruction must be restarted. So instruction must be restarted. Page to replace, right? Which specific option is followed depends on the design of the processor, right? So the page table is full and some of the pages we need to be removed, right? So either first in first out or first in last out or maybe various mechanism they may be possible to engage. When the new page is to be brought into the main memory from secondary storage, the main memory may pull some pages from the main memory must be replaced with a new page. How to choose the which page to replace? This is similar to the replacement algorithm we discussed in a cache. So that is a mapping algorithm we have discussed, that is. So that may be a first in first out, first in last out, round robin, so on, that is. So the principles of locality of preference can also be applied. So locality of preference, so the how long it was there, the replacement strategy similar to the least recently used can be used one such mechanism, since the size of the main memory is relatively higher compared to the cache. Cache was too small, where main memory is little higher. So relatively a large amount of programs and data can be held in the main memory. So minimize the frequency of the transfer between the secondary storage and main memory. Right. So that is a improvement towards the performance of the entire architecture or entire performance of the system. Page may be modified during its residency in the main memory also. When should page be written back to secondary storage? Recall that we encounter similar problem in the context of cache and main memory also. Write through protocol. So what is that write through protocol? Protocol is also called lazy protocol. What does this mean? So the protocol which wherever the miss occur, the particular page miss occur, which may be possible TLB, main memory, secondary memory. If it is miss occur at the main memory and is supposed to be available at secondary storage, so it has to go to the secondary storage and bring that copy. When you brought that copy, in the intention is to provide to the processor which is initially requested. So that is a primary job of the system. So to obey that order of the processor, that particular page we need immediately supplied to the processor. Also, additionally, so that copy we can keep in the main memory also, thinking that in future processor may request the same copy, same page. So in that view, we are keeping those in the main memory also, providing the copy to everybody. For example, main memory, processor, and all this is called write through protocol. It means lazy protocol. It means it giving to everybody though they are not requested. Write back policy or write back protocol. It is postponing to provide the intermediate devices which may be main memory only who are requested, that is especially processor. To them you will provide that copy, and remaining will be providing a copy to remaining the other devices, which will be postponed. That is a write back protocol. So write through protocol cannot be used since it will be incur long delay. So it is giving copy to everybody. So each time a small amount of data is written to the disk. So this completes the concept of the virtual memory as a organization and the looking into the complete address translation. So and also we have seen that translation looks at buffer, that copy abstract copy of the page table. So the page table is a information logbook as a logbook of main memory. So we have seen the page part, how the page part occurs and how to handle them and how to resume after page has arrived to that place. So all those concepts we discuss and there are reference books, Carl Hemacher, Rancic and Jackie, Computer Organization by Tata McGraw-Hill, William Stalling, of course, Computer Organization and Architecture, 9th edition, Pearson publisher. Thanks to coordinator, moderator and subject expert. Thank you one and all.